is consideration for preservation, Florida DOT District 5 preservation practices. This is being presented by Jonathan Jastremski. 2016, he joined the District 5 Structures Maintenance Unit as the engineering section manager. Also presenting on this topic is Matthew Hodges. Matthew joined Florida DOT in 2013.
As was said, my name is Jonathan Jastremski, and here with me is Matthew Hodges, and we are with the Florida Department of Transportation District 5 Structures Maintenance Unit. And we're here to present consideration for preservation. We'll be discussing the diversity of the environmental, the traffic users, and the infrastructure within our district, and how it affects our initial considerations during our needs assessment phase and also our design phase of our bridge maintenance projects. Because we want to basically ensure that we are effectively addressing the need and ensuring a successful project delivery. So a little bit about what we'll be discussing. We'll just take a quick look at FDOT District 5 at a glance to demonstrate the diversity within our district. And then we'll briefly discuss some of the preservation considerations that we go through both at the needs assessment phase and then also during our design phase for our bridge maintenance projects. And then finally, we'll dig a little bit deeper into those considerations by taking a look at 3 current projects that we have going throughout our district, which are currently in construction. So at a glance, District 5 encompasses 9 counties within Central Florida, including Orange County, which we are currently in. So on behalf of our entire district, we'd like to welcome you to District 5. And I hope you've enjoyed your time here so far. So this Google Earth snapshot, it basically shows all of the bridges within our District 5 inventory. So I just wanted to just give you a kind of a brief outlook on like the spread of our inventory and the areas which we have a high density of our bridges, including the I-4 corridor, which runs right through Orange County. So to put some numbers to it, we currently have 1,055 state-owned bridges and 656 local private bridges for a total of over 1,700 bridges within our district. We are responsible for the maintenance of the state-owned bridges that is achieved through bridge maintenance projects that we oversee in our unit, and also asset maintenance contracts that oversee specific areas throughout our district, including the interstate corridors of I-75, I-95, and I-4. As I alluded to at the beginning of the presentation, our district covers a wide area and is very diverse from an environmental, a traffic user demographic, and an infrastructure standpoint, which affects how we assess and approach our bridge maintenance projects. So just to take a look and a brief tour around our district, towards the west of our district we have Marion and Sumter County. It's a very forested rural area, sparsely populated and pretty much dominated by two-way, two-lane roads and pretty much cast-in-place concrete flat slabs or pre-stressed concrete beam bridges. Going a little eastward, we have Lake County, again another very rural and heavily forested area, which is kind of in transition now with the construction of the new Wekiva Parkway, which is a western beltway that goes around the I-4 corridor. Basically, this Wekiva Parkway is causing a lot of new development within this county, and this bridge in specific is environmentally sensitive bridge over the Wekiva River, which is a segmental bridge that had to be heavily vetted through the National Park Service because this is a wild and scenic river. And then finally, we have Orange County, which, like I said, we are currently in right now, and this is a very densely populated county. Basically dominated by the downtown Orlando and the Universal Studios, SeaWorld, and International Drive tourist region. Currently, the I-4 Ultimate P3 expansion project is going on right through this county, which will add toll lanes to the existing I-4 corridor. Going a little southward to Osceola County, a very rural county in makeup, but in Osceola County, we have one of the biggest tourist destinations in the world, which is Walt Disney World. And with that, the infrastructure that can withhold the ginormous amount of tourists that we get on a yearly basis. Then going eastward, we have Volusia County, which is dominated by our beach communities, specifically Daytona Beach and New Smyrna Beach. With our bridge infrastructure dominated by our intercoastal bridges, like this segmental bridge, which leads into Daytona Beach. where aggressive corrosive environment from the sea spray is a driving factor of many of our maintenance projects. And then finally, going southward, we have Brevard County, also heavily beach tourism area. Brevard County's economy is also driven by Port Canaveral and the cruise industry, and also the reviving space industry, including Kennedy Space Center and SpaceX, which necessitate the transportation of a significant cargo throughout the infrastructure in this county. At the bottom of the screen, in that picture of Port Canaveral there, you can see 3 of our movable bridges that we have within District 5 that service Port Canaveral. So this diversity seen throughout our district, including environmental, transportation users, and population density, and tourism, causes us to approach each bridge maintenance project differently. While there are some preservation practices which can take on a more standardized approach, it is important to take more unique, involved projects with a context-sensitive approach in assessment and design to ensure we are effectively addressing the need and ensuring a successful project delivery. First off, during our assessment phase, we want to make sure that we are pinpointing the problem. So we look into our inspection and maintenance history. There's not a better compiled narrative for a bridge's life than looking at the inspection report. So depending on what issue we're looking at, we can determine when did this issue start and how severe is this issue escalating throughout each inspection. And then we also look at the history of maintenance projects throughout for this bridge and to kind of pinpoint, has this been an issue before and how has it been addressed before. Also, the age of the structure can really tell a lot about the bridge. Specifically, when you look at specific design criteria that has changed throughout the years, whether it be concrete mixed designs or concrete cover, you could really pinpoint the reasoning behind a specific issue that a bridge is seeing just by looking at what was the design criteria for when this bridge was built. Finally, environment. Of course, when you're dealing with any area along the coast, you know, the issue of corrosion comes to mind, and a lot of our bridge maintenance projects deals with the corrosion along our coastal bridges. And we also look at, once we decide that a issue has to be addressed, we could take a further look by using some DT and NDT methods, including coring and GPR. And then once we decide to move forward with the project, we have to then go through the design phase. And there are certain considerations during the design phase that we use to make sure that the design is executed adequately. So local coordination. Basically, it's important to have the local coordination on board, especially in a highly tourist area. We want to make sure they're aware of the project up front and that they're kept abreast with any updates throughout the design coordination. Project scheduling, especially in a highly tourist area, there are certain events that dominate our area throughout the year. So it's important to schedule projects effectively so that we are avoiding these issues. And of course, being in Florida, we're in a highly tropical region, and hurricane season is definitely an impending time of year. So we want to try to schedule certain projects to avoid the tropical season. MOT is a factor that can really drive a bridge maintenance project, especially when we're looking at maintaining a bridge deck. MOT can basically dictate how our maintenance project is constructed. And certain aspects can really dictate how we go about an MOT design, including traffic volume, user demographic, safety during construction, and availability of alternate routes. Finally, constructability is always something that we have to take into account, and MOT often dictates the constructability. Basically, constructability is something that's often overlooked with bridge maintenance projects because, especially when dealing with the cost of bridge maintenance projects, constructability aspect is sometimes overlooked and not considered when we estimate the cost of these projects. So now we're going to take a little bit deeper look into these considerations by looking at 3 specific projects that we have going on in our district right now. And Matthew's going to take the lead on the first 2.
So our first project that we're going to discuss is State Road 40 over the Halifax River, Pier 8 repair. This bridge is located in Ormond Beach, which is just north of Daytona. It's a 4-lane, high-level bridge. The bridge was built in the early 1980s in two phases. They built phase one, removed the existing bridge, and then built phase two on the footprint of the old bridge. The two main channel piers started showing distress and deterioration almost immediately. As you can see here, Pier 9 was pretty cracked up. Pier 9 was in worse condition and it received a full repair in 1995. Pier 8 was not as severe, and State Forces carbon fiber wrapped the bridge. Kind of two reasons. One, they wanted to delay in-depth repairs, but also they wanted to test the application and performance of the carbon fiber, which was relatively new in the mid-90s. So kind of looking at the bridge, you have the two main channel piers. The channel is actually pretty shallow, which makes it easier to work on. Access is actually pretty easy to the bridge, which helps. So this failure mode is somewhat atypical for us. A lot of our intercoastal bridges, we see failures due to corrosion, and in District 5, we've had really good luck with impressed current cathodic protection, and we would just slap that on and move on. But that's not the case here. Back in 94, they did a study, and the engineer at the time pointed to a mass concrete pour failure. When we went back to look at the bridge again, we commissioned another report, and they pointed to differential settlement due to the bridge being built in phases and piles being driven to similar depths. In either way, we have been conducting yearly surveys of both the cracking and the elevations, and the pier is stabilized. So, and also the carbon fiber repair has gone past its intended life. I think at the time they thought it'd be fixed within 10 years, and it's been 20 years. So this is an aggressive brackish environment. The bridge still has a lot of life in it, and so it's time for a permanent repair. So some of the complexities, we weren't entirely certain of the condition of the concrete underneath the carbon fiber repair. We didn't want to go and start removing the carbon fiber until we were ready to fix it. Also, the crash wall is right next to the fender system, so it's very tight to work in, especially considering that we would have to do this in the dry with a cofferdam, and also coordinating with permitting facilities because we were working in the water. So we engaged our design consultant, AECOM, and they proposed a phased removal of the deteriorated concrete and installation of a new post-tensioning system to kind of bring it back together to one system. So here you can see elevation shot. There's 20 post-tensioning rods. The crash wall is 21 feet high. So it's a pretty large system. On either end, there's 2-inch thick steel plates that the post-tensioning would be bearing on. And then once the post-tensioning is completed, the whole crash wall will be repoured larger to encapsulate the PT system. So constructability was a concern. We didn't want to reduce the strength of the pier, so it had to be done in multiple phases, actually 6 phases, with at least 2 of the columns fully bonded to the crash wall at any one time, 2 of the 3 columns. And also the EOR came up with a temporary bracing system. Because this was a longer construction project, we know it would go through at least 1 hurricane season, and so we wanted to make sure that the safety of the bridge was first and foremost. So this project's currently under construction. The cofferdam was a huge undertaking. This project would have been probably pretty easy if it wasn't in the water, and a lot of the bid was in the cofferdam itself. The cofferdam's complete and it's dry, and the contractor's completing the first of 6 phases, and things are running smooth. So the second project I would like to talk about is State Road 44 over Barry's and Connors Canal in New Smyrna Beach. New Smyrna is about halfway between Port Canaveral and Daytona, to kind of give you guys an idea of where it's at. These are 2 low-level flat slab bridges. They're along the same corridor, about a half-mile apart from each other. Even though the bridges are newer, only about 20 years old, we're seeing a lot of delaminations and pop-outs and spalls. And these bridges serve both beach access, but also access to the boat ramps. So there's a lot of salt water that drains onto the bridges, which we kind of thought would be the root cause. So we had cores taken by the department, and what they found was that both bridges had very high chlorides. The industry says about 1.2 pounds per cubic yard is the threshold for corrosion. The one bridge had almost 3 times that, and also in the cores they identified active corrosion occurring. So we commissioned a GPR scan to try to figure out if it was the entire bridge or maybe just the westbound lanes for vehicles leaving the beach and boat ramp. We had the GPR scan done, and what we determined was that the entire deck needed attention. So basic solution is just to remove the affected concrete. We couldn't do a full depth removal because it would likely require false work, and we just didn't have the time to get it permitted. It wasn't in the design schedule, nor was it something that we really wanted to take on. So again, we engaged our design consultant, AECOM. They proposed a partial depth hydro demolition, approximately 5 inches in depth to get below the top mat of steel. And the reason that hydro demolition was chosen over conventional demolition was that the hydro demolition would not introduce microfractures into the remaining concrete. So maintenance of traffic was a concern. The residents here, it's a generally older community. They're very vocal and political. So we want to make sure that we provided something that they'd be happy with. The first bridge was really simple to do. It's wide enough that we could do it in 2 phases and just shift traffic. The second bridge wasn't as easy because it was more narrow, and we wouldn't be able to do a simple traffic shift. I initially proposed a 2-way, 1-lane configuration with temporary signals, but the stakeholders hated it. So instead we came up with this 3-phase setup where we had to bifurcate traffic. Typically we would not bifurcate traffic, but speeds are lower and the crash history was favorable, so that's what we ended up doing for the second bridge. So during construction, there was a concern that we would place a bunch of wet concrete onto a thin deck and could cause, possibly cause an issue. So the engineer came up with a pour sequence to where they would pour new concrete onto the negative moment regions first, allow that to cure, and then come back and pour into the positive moment regions so that way stability was maintained. We talked about a strong back system, but this ended up getting the job done. So the project is currently under construction. This is a typical hydro demo setup. On the left is 3 compressors mounted onto a semi-truck, produce about 60,000 PSI. The contractor figures out how much pressure he needs to get to the desired depth, and then on the right is the little buggy that they set the pressure and it just goes on its own. We had some challenges during construction. We had to tweak the maintenance of traffic a little bit. Both a lot of semi-trucks going in and out, but also citizens with boat trailers, trailering boats in. And so we had to tweak it a little bit. Also, we got hit with Hurricane Irma, and since these were low-level bridges, this is actually salt water sitting on the exposed rebar, but we were able to get it dried and cleaned up and moved on. And so when you do a hydro demo, I'm sure you guys are familiar, but it produces a shadow underneath the rebar, so they had to take 8-pound jackhammers and get underneath the rebar. It's been kind of a slow process. There's a lot of work in Central Florida, and labor is actually kind of short right now, but they're getting it done, and the project is on schedule and on budget.
And our final project that we're going to take a look at is actually a project on I-95. It's on I-95 North over County Road 5A, partial deck replacement in Brevard County. Just a little look at the bridge info. It's a 4-span bridge, typical pre-stressed type 3 concrete beams. Here's the typical section. As you can see by the alternate beam spacing to the left, this bridge has been widened to the inside. During that widening project in 2014, an irregular brittle concrete layer was found in 2 bays of span 3 of the bridge deck section during the widening project. Here's just a look at the section view, and the red area is the affected section of the deck. And here's a look in plan of that affected section. So in 2015, coring results at the affected section indicated a high chloride content and low compressive strength in that affected region. 2016, our design began to replace that deck in the affected region, and Kissinger, Campo, and Associates was the EOR. Project considerations: obviously it's an interstate project, public visibility and traffic impacts, MOT and constructability. project scheduling, specifically the MOT challenges. Looking in phase one, we were still able to accommodate 2 lanes of traffic during the replacement, but in phase two, we were unable to provide those 2 lanes of traffic for a standard cast-in-place construction application. So another idea that was brought to the table is the potential for a bifurcated section during construction, which, because it was on an interstate facility, that was quickly thrown out due to safety reasons. So the proposed solution that the EOR brought to the table was a precast deck panels with ultra-high performance concrete and UHPC joints. The benefits of UHPC: obviously rapid cure time. We can get 14 KSI in 3 days. Decreased construction time, 6 days from demo to opening, and obviously reduced MOT time, several weeks down to several days. Some considerations with UHPC: it's a new and evolving material, so cost premium is a factor. Coordination with the supplier for installation, the sensitivity to high temperatures during mixing, and leak-proof formwork is necessary because in its initial state, UHPC is very fluid, so we have to make sure that all the formwork is leak-proof. So here's just a few details from the plans showing the UHPC joints. As you can see, because it's such high strength, your overall joint width are minimized compared to normal concrete construction. On April 2nd, the construction commenced, and at the time of submission, construction was still going on, and as of this afternoon, they were pouring the UHPC. So just an overall synopsis. All projects are not created equal. It's important to do that upfront consideration when looking at bridge maintenance projects. We want to fix the problem versus placing a bandage. We want to make sure that we are addressing the problem effectively so that we don't have issues down the road. And a little upfront consideration goes a long way. So I just wanted to thank you for your attention, and if you guys have any questions.
In the second project you described that you placed the concrete over the piers first and then placed the concrete in the positive bending regions. Was there concerns about cracking developing in the negative bending regions due to the deflections caused by any positive bending deflections in the second phase?
Yes, that was a consideration by the EOR, and he determined that he considered that in his design, and he determined it wasn't a concern.
UHPC, the details. Why did you choose this detail, which is the complicated one compared to simple rebars?
Could you elaborate a little bit?
Well, I mean, the latest detail is just simple 2 rebars in the connection and call it good. It looks to me you had the loop bars and 2 bars in the connection or in the joint.
Correct.
Do you know?
Yeah, I can't speak on behalf of the EOR, but that was his proposed design, and that is what we went with. I wish I could provide more information, but yeah.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.